So in this video, I'm going to show you something that we do to make Gitwit very effective at writing code that works well with third-party Node.js dependencies. So let's do an example. I would like to add some icons to my app. And you'll notice that right away, Gitwit adds a line here at the top of the file that uses a dependency. And straight out of the box, this dependency gets installed and it works. If we go to the package.json, we'll see that both of actually that dependency and then the other one that was right below it, those have both been added with 2 version numbers. Now, these are actually not the latest versions of the packages. They're probably a few months old. Why don't we use the latest versions? Well, the code is generated with an LLM, in this case GPT 3.5, and every LLM has a knowledge cutoff date, meaning its knowledge of these third-party dependencies out in the world is not completely up to date. So in this case, we're actually installing the version of this dependency which is closest up to the knowledge cutoff date of the LLM. And we know that this works pretty well. How do we know that, given that there are so many possible dependencies? Well, we've actually taken a list of the most common 50 React JavaScript dependencies, and we run tests of Gitwit on all of these dependencies to see how it's working. So in this case, you can see a test that was done using GPT 3.5, Gitwit, and the latest version of each dependency used in the generated code. And you can see here there was a success rate of 53%. And that depends, of course, on which dependency. Some of them don't work at all, some of them work pretty well. And then here, we have another test case where we're using dependency matching. So we're using either a hard-coded version of the dependency, or we're making a request to NPM to find the version of that dependency which is closest leading up to the knowledge cutoff date of the LLM. And we can see right away that this gives much fewer errors, and that's both when building the code and also when running the code. And that's something that is built into our evaluation framework that lets us test this very easily. So if we would take the results from both of these experiments and we compare them, we get this nice table. And what we see here is that for approximately a third of the most common React JavaScript dependencies, those don't work with the latest dependencies, but they do work when we use this dependency matching. And that really only uses a version of the dependency that's a couple or a few months old. But given that some of these dependencies interfaces change very fast, this is surprisingly effective. And in this chart, we just see a plot of each of the dates that we have found to be successful for various dependencies. So you can see that for most of them, just leaving them here at the knowledge cutoff date works perfectly, but for some of them, shifting that date a little back or shifting that date a little forward works better. And that kind of makes sense because we know that GPT 3.5 was trained on a bunch of different data sources from the internet, and not all of the documentation that was fed to it would have been from exactly the same date. So this is something that we dynamically adjust in our system, and we find that it works pretty well. And this is one of the reasons why Gitwit is so good at handling dependencies. It's a simple thing that we do, but it goes a long way in reducing the error rate of the code that we generate.